All right. Hello, everyone, and welcome to our multi-cloud happenings. I know it was probably a long weekend for everybody. So, yeah, I hope you enjoyed the long weekend and were able to enjoy it with family and friends. So, hi, my name's Tammy Bednar, and I'm here to host our multi-cloud happenings for today. And it's May 30th. I can't believe it's already almost half a year's already gone. But I'm really excited to talk about this topic because it's very important when it comes to high availability of your applications. And so we're going to talk about the Oracle Database Service for Azure cross-region disaster recovery best practices. And so we have, oh, and by the way, I just have to add this and say, this is intended for general information. And we, just to let you know, so you can't write this into a contract. So let's go ahead and get started. Okay, so our experts today, joining us is Suzanne Holliday. Hi, Suzanne.
Hi, Tammy.
All right, and Suzanne works on our Exadata database services and our base database services. And then we also have Sinan Toma. Hi, Sinan.
Hello, Tammy. Hello, everyone.
Thank you for joining today. Sinan has a great blog out there. So anytime you run across his blog, please take a look at it. It has some great information. And then also we have Thomas. Pronounce your last name for us, Thomas. I don't want to butcher it.
Hi, Tammy. Yeah, my last name is pronounced Van Bugenhout. It's a Dutch sounding name. So glad to be here. Thank you for inviting me.
Fantastic. Okay, so let's go ahead and get started. And we want to talk about the flexible architectures of multi-cloud because we want to make sure we put everybody on the same page. So Suzanne, you want to kick us off with that? Oh, you're on mute, Suzanne.
I'm sorry. Okay. Yeah. So for the purpose of our strategic products with the Microsoft services that we offer, we just like to make an explanation up front of what we actually mean by a full stack and a split stack. So here we're depicting a full stack whereby we have the actual full stack of the application is running in one cloud. So here in the diagram, we're showing the e-business suite running on Exadata cloud service. And, here we've got the fact that we've got, any kind of number of workloads that can be run. And if we've got in the sense of network requirements, data integration pipeline, if it uses batch processing, it's not network, sensitive to the network. So it doesn't need that low latency, which obviously is applicable to any kind of stack. But if you go ahead, Sammy, with the next one, please. And here we have a split stack application. And this really is what we're talking about, like I said earlier, with our Microsoft focused services, because typically we've got one piece of the application. If it's the OCI interconnect, it can run either in OCI or in Azure. And then at the back end, we would have the database running in either cloud as well. However, with Oracle Database Service for Azure, it will always be the case that the application is running in Azure and the database is running in the OCI database services at the back end, which we're going to take a run through as well on the next slide. Next slide, Tammy, please. You go ahead, Tammy. You can introduce the services.
Sorry, that mouse does it sometimes. Hold on one second. Okay, there we go. So as Suzanne talked about, the different architectures involves our database services, and that's really what we focused on. And we have different options, or I should say flexible options for everyone in order to choose the best database that is available for you to run your applications on. And if we start at the far left, which is our autonomous database, it's the easiest database service. And it can be, you can deploy it either in a shared model or a dedicated Exadata model, and it becomes fully managed, which means this really, we do all the manual tasks. We help you with the patching, we make sure we implement the best configurations for the efficient use of your applications, or the best application capabilities for performance, availability, and things like that. because it's fully managed, it really eliminates this human error and any workload or any that you can see. I mean, we've been around our databases for a long time. We know anytime we have to do anything manual, it's possible to have an error or issue the wrong command. I've done it several times. So, and also with the autonomous database, it gives you any scale, and it's and of course, as I said, we've built configurations for high availability. The next service that we have available to you is the Exadata database service. It's a very flexible, and you have a dedicated Exadata capability. When we say dedicated Exadata, that means that it is comprised in an architecture of database servers and storage servers that are totally dedicated to your databases, your workloads. But it's a co-managed service, which means that Oracle and we work together to ensure that the different components and architecture are patched, that we also scan for any kind of vulnerabilities automatically. But you have full administrative control. We provide the patches to you when it comes to the VM, the operating system, the grid infrastructure, as well as the databases. We provide them to you. That would include any patches or updates that is required by the cloud, and then you get to choose when to apply them. But I could say that, when we say you choose, we want to keep them up to date as fully as possible so that you have the best experience with the database and your applications. Now, the Exadata database service supports I know we have all enterprise workloads on the slide here, but it really supports any workload that you may have, anywhere from OLTP to analytics and anything in between or combined thereof. So we're really excited about the Exadata database service. And then finally, we have the base database service, which is more of a traditional capability to run your enterprise and standard edition databases. It runs on VMs, on compute shared on x86 platforms. It is a co-managed service, just like on our Exadata service, which we make sure that the infrastructure is patched, and then we provide you the patches for you to patch your GI and your databases. So again, you have full administrative control within the base database service, and all database features are included, including Oracle RAC on all of these services as well. So that gives you an idea of the architecture and our database services that are available on these services. Okay, so now, Suzanne, I'm going to pass this back to you to talk about the Oracle database service for Microsoft Azure.
Thank you, Tammy. Hi, everybody. I just want to take you through just a very brief overview of what Oracle Database Service for Azure is. Oracle is really laser focused on its multi-cloud strategy, and we're investing heavily because we want to give you as our customers choice, and we want to remove any friction when you're deploying workloads across multiple clouds. So we go back to September 2019 when Oracle and Microsoft, we forged a strategic partnership. And this was to provide you the best technology capabilities to connect Oracle and Azure with low end-to-end latency. And that at the time was part of the OCI Azure Interconnect strategy. And as part of that strategy, and later last year in July, we then brought out Oracle Database Service for Azure as well. So this is really providing you as the customer the best cloud database services in the industry to connect with Azure applications, remove any friction, make it very, very simple. But furthermore, and these are the two major selling points of this service, is the fact that it is managed connectivity and that you have a familiar Azure-like experience that is very, very simple and takes you through a UI in order to connect the Azure applications to the database. We have 12 regions today that support both the OCI Azure Interconnect and the Oracle Database Service for Azure services. And, we're heavily investing in this partnership to drive innovation, performance, and availability. So in just a couple of clicks, your Oracle Database Service for Azure, you connect your Azure subscription with your OCI tenancy. It automates the network configuration. It would use Azure Active Directory credentials to authenticate users across OCI and Azure. And it creates this graceful coexistence of Azure applications connecting to our database services. And this is like it was if it was operating in one cloud over a very secure high-speed interconnect. And yeah, it's designed so that we can not only simplify the development of innovative applications, but also our developers and the architecture can take advantage of the converged database as well, which is fully supported by the services that we support for OCI, for Oracle Database Service for Azure, which is Autonomous Database, Shared, Oracle Exadata Database Service, and Oracle Base Database Service. And we recently added MySQL HeatWave as well. Next slide, please, Tammy. Okay, so the reason why we define Oracle Database Service for Azure, and I'll briefly abbreviate this later to Oracle DB for Azure, is because it's a managed service, because the actual way in which it connects and the way in which we've architected it is completely managed by Oracle. And in the fact that we're managing the connectivity, allowing customers who connect their Azure applications to the Oracle Database Services, and it simplifies the provisioning. So you can, as a customer, can really concentrate on your data and your development and not be completely immersed in building and, building up and tearing down interconnects, or, actually making two clouds connect together. So that's the advantage. And on this diagram here, you can see that we have Azure depicted on the left, OCI on the right. And just to make clear that the Oracle database itself resides in OCI, and that the OCI account is linked to your Azure account over this, like I previously mentioned, this Oracle managed private cross-cloud interconnect. We have implemented a hub and spoke topology, and the hub virtual network is the central point of the connectivity for the traffic that enters and leaves the network. And the architecture provides a highly scalable and modular design for connecting the multiple spokes. So the Exadata and the base database service, they connect, and as you can see in this diagram here, we've got them depicted. The presentation is like it's a peering relationship, and we have a customer selected VNet and a VNet in the Oracle Azure tenant. And then we link those with the interconnect to provide this high performance, low latency private tunnel for, the network traffic dedicated to each customer. And from that hub and spoke architecture, we encapsulate the data and send it over the Oracle provisioned interconnect. So what we're doing is we're automatically creating the network plumbing between the cloud environments, and we manage the Service Azure Express route and the OCI Fast Connect tenancy that you connect to as a customer. And this is how we can actually absorb the Azure Express route ingress and egress charges, which traverse over the Oracle DB for Azure interconnect. And just as a side note, just to make clear, because we are actually utilizing VNet peering in this multiplexed managed architecture, you as a customer would incur the inbound and outbound VNet peering charges within the same region, but they're very, very nominal. And we're really saving you as a customer the ingress and egress charges for both Express Route and OCI Fast Connect, which hit you much harder. And also the data port charges for the Express Route and Fast Connect are free of charge to you as a customer as well. Next slide, please, Sammy. So we have this infographic just as a very, very abstracted way of depicting how to go through the entire process of standing up your environment. And this starts with the prereqs. We've gone through this in a very detailed session for the very first multi-cloud happenings that we did. So I'll just briefly skim over this, but what we're doing here is we're making sure that the OCI tenancy has supporting identity domains, and we create an OCI account during the sign up. We've got the home region of the OCI account must be an OCI Azure Interconnect region. You've got your OCI VCN or virtual cloud network for pairing with the corresponding Azure VNet. And they need to, your VNet needs to be created beforehand, and you have to make sure that in both cases you've got non-overlapping CIDR blocks between your Azure VNets and your OCI VCNs. So in this onboarding on this picture here, they're the prerequisites. The next stage is your onboarding part, where you're doing the account linking, as I've previously described, and your subscription linking as well. And when you're doing that, you've got a choice of two models. You've got either a fully automated configuration, and that links the Azure subscriptions that you specify to Oracle DB for Azure, and it configures the users and permissions for you as well. And the identity federation for your OCI account is created for you with the Azure Active Directory as the identity provider. And if you don't have a new existing OCI account, a new account is created for you during the sign up as well. And then on the other side, we have the guided account linking. And this requires that you grant the minimum number of permissions. So I will go through those in a second. So basically we have, when we do that setup, we have the Azure user account needs a certain amount of privileges in order, and the ownership of the Azure subscriptions in order to link to OCI. So these are like the global administrator or your application administrator or a privileged role administrator. And they could be removed after the linking has been done. And that's what we mean here when we say more minimum number of privileges, because when you go through the guided account linking, the software that you need to complete your ODSA deployment just needs less in that case. And your guided account linking will take a bit longer, as you must do the user role and user group administration yourself. And then you create your user federation with your OCI Azure account with Active Directory if you wish to do so. And the identity provider obviously is optional there. And then what we do is then what would happen is you would federate the OCI, IAM, and AAD to allow you to log into the regular OCI console with your Azure credentials as well, if you wish to do so. So as part of that second step, we have three major things that happen. We have to assign the users to the Oracle DB for Azure Enterprise application, and that's something that our development team created within Azure, and that so that you have the required ARM roles as well. And then the second stage is that you need to assign the contributor role that we will be using for ODSA, and that has the ability to access and manage Oracle DB for Azure resources, including the databases, the database system, and networking as well. And the last one is to assign the Oracle DB for Azure groups. So these groups will control the access to the Oracle DB for Azure resources. And then you would go ahead and create your database itself through the Oracle DB for Azure portal. And that's a very nice Azure-like experience, which will guide you through that. And then as your final step, you connect your Azure application to the Oracle database using the database connection string that the Azure applications will need to access the database. And you do that in the same way as you would do today. Except in Oracle DB for Azure, each database resource obtains an Azure connection string to connect to the database, and during provision it creates the network connections between the cloud environments as well. And then you'll find that the Oracle DB for Azure defines the DNS entries and connection strings needed to access everything from Azure. So that's just a quick run through from steps 1 to 5 that the infographic summarizes. And with no further ado, we can now get into the blog that OCI have actually written that Thomas is going to tell us about. So please, Thomas, go ahead.
Thank you, Suzanne. Thank you, Tammy, for the time to promote our blog. Yes, our team has created a blog to describe the best practices to set up disaster recovery cross-region. What's important there is to know what we mean with cross-region. It means that you can set up disaster recovery across different interconnected regions in OCI. So it means that we have defined 12 geographical locations, 12 regions where we have set up an Azure OCI interconnect, which is also enabled for Oracle Database Service for Azure. It does not mean that you can go from one geolocation in Azure to another geolocation in OCI. It's important to know that because sometimes it gets a bit misinterpreted. It means that the disaster recovery is set up between a region, let's say, call it a region per OCI Azure, where we have a primary site on the in Amsterdam, for instance, and a standby site somewhere else located in another interconnected region. So the block talks about the best practices, and it will also show you which regions are available where we have the interconnect, where Oracle Database Service for Azure is available, so that you can choose the best regions or your regions where you want to implement this. I would like to invite you to read the blog, and together with what we've learned or we will learn from Suzanne and Sinan today, I think it's a perfect match, and you will be set to set up your cross-region disaster recovery. I think we can go over to Sinan.
Thank you, Thomas. So then let's start to talk about disaster recovery. When talking about disaster recovery, we need to talk about the technology Oracle Database uses for disaster recovery, which is Oracle Data Guard and Oracle Active Data Guard, that uses synchronous or asynchronous replication of the radio data from the in-memory. So this is very different from the storage replication. Storage replication replicates everything, the good and the bad things, while Data Guard only replicates the good things. And if there is something bad happening on the storage level, this won't be replicated, and the standby side will be protected. The standby side can be passive and distant there just for failover and switchover scenarios, or if you are using Active Data Guard, active read-only for applications, or even with 19C, which is we call read mostly, because even the standby database is open for DML, occasionally needed by some applications. This will be redirected to the primary, but this is perfectly fine to be executed on the standby. It also provides automatic failover capabilities with faster start failover, depending on synchronous or asynchronous replication, zero or near zero data loss. We will talk more about this in the next slide. And also, as mentioned, continuous data validation to make sure that data are really protected on the standby side. And Data Guard also have other use cases, for example, for migrations and upgrades, to simplify these tasks for migrating the database to the cloud, or even to any other destination, and upgrade between major release updates. So next slide, please. So the radio transport modes, you can choose asynchronous replication, which means as soon as the application commits the transaction, the radio data are written to the primary online radio logs. The commit acknowledgement is getting back to the primary to the application. This is what you usually know from the day-to-day work with the Oracle database. Then later on, at some point in time, usually immediately after that, but not synchronous, the radio is transported to the standby database and then written to the standby radio logs. Another mode is the fast sync, which means when the application commits, the radio data is transferred to the standby side, and as soon as it is written to the in memory and on the standby side, the commit is sent back to the standby. So here we are not waiting for the I/O, which usually takes a bit more on the standby side, to the data to be written to the standby radio logs. And this is why it's called fast sync. This is a bit faster than the sync replication, which comes next. That means that the acknowledgement is getting back to the application and to the end users after the data is written to the standby radio logs. which provides more protection than the fast sync, because data is not only written in memory, but also on the physical disk device into the standby radio logs. Next. And this is what you also see in the protection modes. And what are they called? The maximum protection on the very right side, because data is written to the standby radio logs on the disk device on the standby side before it is acknowledgement that is committed. On the very left side, this is the maximum performance. We are not waiting at all. And in between fast sync, you can even use it with maximum sync or fast sync with the maximum availability protection mode. Okay, next. And what mode do you use if you are using synchronous or asynchronous? This mainly depends on your application's requirements to tolerate zero data loss or near zero data loss, and what impact this have to applications performance. Usually when the primary and the standby database are in the same region, when you do across ADs, this is usually could be used sync, because these availability domains are very close to each other. But when you are using cross-region disaster recovery and the standby region or the DR region is quite far away from the primary region, the application performance might be impacted. Might be, it's not necessarily the case. It might be the case. It depends on the application. And this is why we always recommend to test the commit time between the primary and the standby database that is needed for synchronous and for asynchronous replication by data guard, so you can choose and decide to use synchronous or asynchronous replication. Oracle provides a tool for this, which is called Aura TCP test. It's for free. You can download it from this must node mentioned above on the slide, and it's very easy and straightforward to use and to measure the time needed for synchronous, for fast sync, and for throughput, because with asynchronous replication, you don't have any wait time between the two regions, but with the asynchronous, you get the opportunity to measure the throughput between the two regions. Next, please. So next, we come to how to deploy the data guard when using Oracle Database Service for Azure. And this slide, we have seen it before. You have the primary region and you have the DR region. In this case, in this example, Ashburn region on the top and the San Jose region at the bottom. And the next step, or the first step, what you will do is use the database service for Azure, the multi-cloud console, and the provision 2 standalone databases in each region. So next, please, Tammy. So you just go to the first region and provision 1 database, and go to the second region and provision 1 independent database in that region. The VCNs, as Suzanne mentioned earlier, will be created in the background in OCI. So in the next step, you will go there and peer those OCI VCNs using the remote peering capabilities provided by OCI, and open the listener port in the VCN, and the VCN rules, and the routing rules, and security lists. And in the next step, you have these 2 databases that are yet just standalone databases where the VCNs are peered. You will provision data guard manually and set up data guard manually, as you would do it with every Oracle database, whether it is running in the cloud or on a premises or in a hybrid cloud configuration. Next, please. And this process is described in the documentation, but also described in Oracle Life Labs, Oracle Database Hybrid Active Data Guard. You have the link here. Just go to this Life Lab, and this is explained very in detail, step-by-step explanation, how to set up data guard between databases. This Life Lab is explicitly for hybrid active data guard, but it doesn't matter. It's just exactly the same process. You follow the same steps, whether the standby database is just in another region or in OCI while your primary database is on premises. Okay, next, please. And with that, let's have a look at best practices and the situation when we are using split stack architecture for cross-region disaster recovery scenarios using Oracle Database Service for Azure. So on the left side, we have, in this case, in the same region, actually, but this could be, just AD1 across regions. This is what the title also says. We have region 1 on the top left side, and then OCI region 2 on the bottom left side. And this is what we described in the previous slides. We have two Oracle databases, networks are peered, and data guard is set up between region 1 and region 2. At the same time, in each region, we have the network link between OCI and Azure. So these regions are peered with each other's or connected with each other's using Oracle Database Service for Azure. And the application is also replicated from Azure Region 1 to Azure Region 2. In the starting configuration, you just have your primary application in Region 1 connected to the primary database in OCI Region 1, and everything is fine. The primary database on the top left side is replicating via data guard, and any changes in your application are also being replicated, for example, using rsync or whatever replication mechanism are you using for your application to your application in the DR side. Now, next slide, please. So what happens if your Azure region or your primary application goes down or it's taken offline due to maintenance operations? In this case, you will switch over the Oracle database to the standby database and make that standby database in the second region the primary database. So the new primary application, now it is connected to the new primary database, which is in the same region 2 at the bottom of the slide, where these two regions, the Azure region and the OCI region, are very close to each other. And Oracle Database Service for Azure provides the network link and provides the low latency between the primary application and the primary database. Now, if the primary region in Azure on the top right side became available again, you can decide to keep the configuration as is, or switch back both the primary application and the primary database back again to the primary region. This is then up to you. Next slide, please. Similarly, if the primary OCI region or the primary database fails, in this case, you will need to switch over the application. So here again, you have the primary application and the primary database again in region 2, in Azure and in OCI. So always having the primary and application and the primary database next to each other in the same geographical region. Here again, if the primary database become available again, you can decide to switch back to region 1, both application and the database, or keep running in region 2. Next, please. Another situation is when you are using active data guard, where the standby database is open read-only or read-mostly, what's called, with the ML redirect. In this case, your application in region 2, which is the DR region, this can also be used as a read-only application, do some analytics, and using the standby database for read-only or read-mostly workloads, taking the load off the primary database in this case, and also using all the resources that are provisioned in region 2 and making use of those instead of those just being there and waiting to be used in case of a disaster or in case of a switchover for maintenance operations. And with that, back to you, Susan and Tammy, to talk about the Life Lab and the next slides.
Excellent. Thank you so much, Sinan. That was very interesting. Sinan, I think you mentioned about the Oracle Live Labs, and this is, again, another link to the Live Labs that is available for you to take a look at. Even if you don't have a system to run Live Labs, this has a lot of good detailed information in it about how to set your hybrid data guard up as well. Oops. Okay. Here are a number of links for resources. We have our Oracle database service for Azure. We have some documentation. We also have a number of great blogs out there that have a lot of details in it. And then, of course, we have some videos out there as well. We'll get this information out to you on where you can find all those links. We'll get that posted. And then finally, as a summary slide, our Oracle database service for Azure. This provides best practice. We hope that you find that this is good for you to provide best practice disaster recovery with our multi-cloud solutions. And, we want to consider the DR region performance as you set this up for your recovery time objective and your recovery point objectives as well for both your database and your application layers. And then DataGuard is provisioned manually right now for our Oracle database service and for Azure cross-region disaster recovery. And DataGuard availability in the Oracle database for Azure portal is on the roadmap. So we continue to make great strides with our application portal to make things more efficient and easier for you to configure this solution. Before we get to Q&A, I just want to say, we have an external Slack channel. We would love for you guys to join us in our discussions. We have some great discussions on our Slack channel. We also have our own AI chatbots as well. So if you have questions about our DBaaS CLI or Oracle or OCI CLI, we have 2 chatbots out there, Ask Ed and Ask Debbie, on our Slack channel. And we'd love for you to join us as well for all the great information. We also have a number of announcements whenever there's some interesting webcasts, and blogs are also released. Okay, so now is the great time for Q&A. And we did have a question came in from Mahesh. He wants to know that in this DataGuard HA solution, does this require 2 different Azure subscriptions, one on the primary and on the second, and also one on the second DR site of Azure? Any of our experts want to join and answer that? Oh, great.
Let's jump on, but go ahead, Thomas.
Well, you don't really need a separate subscription, but your resource group is region dependent. So you can use the same subscription, but you have to have a different resource group for each VNet that you want to provision in Azure.
Great. Hopefully that answered your question, Mahesh. We didn't have any other open questions. If anybody has any questions, please post those in Q&A. We have our experts here to help with any of these questions. While we're waiting from any last comments or some comments from our panel on this solution. I know.
Well, I think the only thing that we said to, as you said already in closing, Tammy, is the fact that right now we're talking about cross-region data guard or data disaster recovery specifically with Oracle Database Service for Azure. And the fact that we're doing a manual data guard configuration is seen and explained in great detail. And the fact is that we obviously do want to bring the functionality of the Oracle Data Guard into the Oracle Database Service for Azure portal, and that's on the roadmap. And we will keep you updated as to the progress, but we can't give dates right now about that.
Right.
So the intention is that we want our customers to be able to, provision data guard from the Oracle DB for Azure portal. But for right now, we're doing this webcast to make people aware that we do have an MAA solution for our applications that are, deployed in Azure wanting to connect to Oracle databases through this service.
Great. Thanks, Suzanne. Sinan or Thomas? No,
I have nothing to add.
Okay, thanks, Thomas. And Sinan, I know you've done some testing on this as well. So you've given us all your best practices and your experience as well to set this up.
Yeah, we tested this with base database, and it works fine. Setting up the data guard manually is a standard procedure that we are following all the time. It is the same procedure we follow on premises, or we follow for hybrid DR, as mentioned in the live lab. But also if we are doing manual data guard configuration within OCI, for example, in some cases when customers need manual DR, when the capability is not yet available in OCI, we follow the same procedure.
Great. Okay. Oh, we have a question that came in. Hopefully, could Suzanne repeat her explanation of the networking costs, ingress, egress costs from Azure? You're on mute, Suzanne.
Sorry. Thank you. Yeah, sure. I was explaining beforehand that we have architected the actual managed connectivity in a way that we multiplex, and by doing so we are providing that architecture to ensure that we can provide and cover the ingress and egress charges for both Azure Express Route and OCI Fast Connect as well, which obviously within OCI they're included anyway. But when we're actually architecting these solutions from between one cloud to another, then we make sure that the ingress and egress charges are included. And we, like Thomas explained, we're always deploying the application and the database inside the same region. What Thomas meant by that is we're not actually going to put the application, for example, in Amsterdam and the database in Frankfurt and expect the latency that we can offer as proof, which our customers have successfully gleaned before. This is always within the same region. It's a multiplex architecture, and therefore the ingress and the egress charges are actually included. However, as I mentioned as well, because the architecture involves VNet peering, the VNet peering inbound and outbound charges will apply for customers. And these are very, very nominal compared to, let's say, your egress charges, and ingress charges that you would incur. So if you go into the Azure site today, it's charged per gig, and is very, very nominal compared to what you would charge for ingress and egress. But we just want to be completely transparent with the costs, because there is the VNet peering, but the ingress and egress are completely included, as are the port charges as well for Azure Express Route and OCI. So yeah, did that fully answer your question there?
I hope so. If not, come on back to us and we'll answer. We'll ask you that.
Yeah, we didn't see you ask that. Yeah.
That's okay. And then Krishna asked a great question. What's the procedure to enable data guard for autonomous database?
Yeah, so for autonomous database or autonomous data guard, in that case, it follows another procedure, another technology that's being used for shared. And in this case, And how about Autonomous Data Guard? This is out of the scope for this session today. We are more focusing on the managed database services. I guess we will have a further session for Autonomous Database when this becomes available in the multi-cloud console. Then we will cover this in more detail. If you have a specific customer use case, feel free to reach out to us directly to discuss this in a one-to-one session that we can help you set up an environment that fulfill the customer's requirement, and we are happy to work with you together towards this.
Fantastic. Oh, okay. Thank you, Sinan. Krishna says, thank you so much. Thank you, Krishna, for joining us today. Okay, so I think that wraps up all our questions. This was some great information that we covered today, you guys covered today. And I think it's going to be very helpful for our customers to continue with their multi-cloud solutions and providing high availability to their applications as well. Okay, with that, I think we'll sign off. I hope you join us next month for our next multi-cloud happenings. And I hope and if you have any topics that you would like to hear about, please post those in Q&A and ask Tom, and we'd be more than happy to bring you that information. With that, thank you, Thomas, Suzanne, and Sinan. Have a fantastic day. Thank you all for joining us. Have a great week as well. We'll see you next month. Bye.
Bye-bye.
Thank you. Bye-bye.